Right. So, networking. All right. First question. Let's say we wanted to write a function that sends a request to an endpoint. What type will we typically instantiate before the others? The answer is usually you'll do URL. Looking back, I'm not a big fan of this question because you could do it in any order you want. But yeah, you'll also typically be using the shared URL session, so you're not going to be instantiating it yourself. Kind of a trick question. I don't know. We'll see. Question 2, when building a URL request, sometimes we need to set these properties. The HTTP method being set to post and the value being set to application JSON and content type. We need to do this when we are making a post request with JSON in the HTTP body. If we were making a put, patch, or delete request, we would put patch or delete in the HTTP method accordingly. If JSON request isn't a thing, and post request with HTTP header format needs to be in JSON, this is modifying the body, not the header. If we wanted to call an end, so that was question 2. Question 3, if we want to call an endpoint that accepts a put request, which async method on the shared URL session is the most appropriate to use? And the answer for this is upload. Put is specifically uploading a resource to a specific path on a RESTful service. So typically you'll use upload for that. Yep. That said, put requests don't get used very much, but it's good to know that it's there if you ever run into it. Consider the following code. We have this URL session shared data for request. What's the correct way to get access to the status code? The correct way is to cast the response from URL response, which is what we always get from a data for or upload or whatever, any call from URL session where we're hitting the network. We get a URL response back and a data object that we decompile and decompose into a tuple. We can cast the response from URL response to HTTP URL response and then access the status code property on that instance. So once we've cast it to HTTP response, we can access the status code. Next up, we're going to look at some codable types. So when we attempt to decode this particular struct from this particular JSON, you will run into this error. I would expect if you did the assignment, you ran into this error. So fair question, I think. What is causing this error? The answer is that the current value JSON response has an underscore, so it is snake case is what it's called, compared to what is written here in the struct where there is no underscore and value has the V capitalized, which is called camel case. So that is the issue. There's a mismatch there. There's a few ways to solve that, but that's what causes the error. And then for question 6, let's say we hit an endpoint that returns an array of counters instead of just a single counter. Specifically, when you are calling decode on JSON decoder, and you are passing it the type information of what type you are trying to decode into, you need to give it the type and then .self. So the type that it's becoming, that the JSON becomes, the total overall JSON object becomes, needs to have .self added. So in this case, it's an array of counters, .self. If we were to do just counter.self, that would be looking for a single instance of counter. If we did this counter space self, it wouldn't compile. And then if we did an array of counter.self here, it probably also wouldn't compile, but this is basically saying an array of counter types, which you could use for something, for things that like maybe subclass counter. So yeah, so that's 5 and 6. 7, semantic versioning. We've got our major version X, our minor version Y, and our patch version Z. This is just how semantic versioning is. If you'll recall, major versions are backwards incompatible changes. Minor versions are changes that add functionality but are backwards compatible, and patches are backwards compatible bug fixes. When building a public-facing local API, also known as a library, what things are important to think about? The important things to consider are which functions and types should be visible to the clients, so what's public, what's private, what's internal, and the purpose of the API and what clients expect from it. This helps you define which functions are public and private and internal, and which types. You need to know why you're building the API. How many clients will be using the API doesn't factor in for a local API or library. That's not relevant to you. They're getting a copy of the code that they are embedding in their app. If you were creating a service API that was hosted on the web, you would need to worry about how many clients are using the API, because if you have a lot of people using your API, you need to be able to handle that to prevent yourself from going down to like a denial of service attack, basically. And then how to host the API on the web. It's just not really, again, that's something that's more important for building a service API than a local API. Yeah, when you're building a library, how you host it isn't terribly important. It's not something you think about while you're building it. Maybe when you're distributing it, do I put it on GitHub or do I put it on Bitbucket? I don't know, right? But like, that's not really, it's not an important decision as you're building the API. Dependency hell is all of these things. It's when your dependencies suck because there's too many of them and they're too interrelated and you just can't do anything and it's just bad. And then lastly, every time you call a URL at a particular service API, if you get the same resource, even if it's been changed, it does have the same basic information and it is the same piece of data, even if it's been modified. If it's mutable, it's been modified. And you expect that that particular URL path that you're using will always be the same for that particular resource as long as it exists. What sort of service API are you accessing? And the answer is RESTful. That is a RESTful service API. It's one of the key definitions of REST, which is like resource state trans something or other. I can never remember off the top of my head. It's not important. Yep. Any questions about the quiz and the quiz review and any of the questions in it? Yes, what's up?
For the XYZ question, I got it all wrong because I assume that is the sequence of XYZ, but you know, like it will get shuffled.
Oh, it shuffled these?
Yeah, I think so.
Oh,
I was
weird.
like, okay, I got it all wrong because I only look at the XYZ order. So.
Oh, yeah. No, wait.
Oh well.
Oh, because it adds in. No, yeah.
Yeah, just let you know.
Yeah, shuffle questions. This should not have been checked. I apologize. Yeah, hopefully that didn't mess up too many folks, but yeah, I'll probably drop some of these questions and then do the curve. Because yeah, some of these were not great. Yeah, this was the fastest I ever built a quiz, so it's got some errors in it. So apologies. Any other questions about the quiz before we do a quick 5-minute break? All right, cool. We will do 5 minutes.